Okay, so we are starting our chapter 5 trig, and it's all about trig identities. And today we are going to focus on section 5.1, which is all about fundamental identities. Okay, so with them, we have 4 fundamental identities that we need to memorize. The first one is known as the reciprocal identity. So with the reciprocal identity, there are 6 trig functions. So that means that there are 6 reciprocal identities. So we have sine of theta is equal to cosecant of theta. And then it's reciprocal. So cosecant is now the same as 1 over sine. We have cosine of theta, and that is equal to 1 over secant of theta, or vice versa. Secant is equal to 1 over cosine. And then tangent. So tangent of theta, 1 over cotangent of theta, and then we can flip those around. Cotangent is 1 over tangent. Now, something to kind of keep in mind about these reciprocal identities is that when you multiply reciprocals, so let's say we had a reciprocal of 2/3, we want to multiply it by 3/2. Notice that you get 6 over 6, so it'll always give you 1. So in reality, if you multiply sine of theta by the cosecant of theta, as long as you know that they're reciprocals of each other, we know that that will always equal 1. Cosine of theta times our secant of theta, again, the reciprocals, they'll give you 1. And then tangent of theta times cotangent of theta is also equal to 1. Because you can always change one of these trig functions into the other one. Our second identity is your quotient identity. So our 2 quotient identities have to do with tangent and cotangent. So tangent is made up of sine and cosine. Because if you think about it back into when we were learning our unit circle, tangent is made up of y over x, and we consider now the y as the sine coordinate and the x as the cosine coordinate. So if we know those 2 values, now we can write it in an identity, which means its reciprocal cotangent just means that it's cosine over sine. So those are your quotient identities. Now, the next identity is very important, and it can be manipulated in a lot of different ways, right? So this is our third one. It's called the Pythagorean identities, and it follows the Pythagorean theorem. Okay, so I'm actually going to derive these equations and show you how I get the first, the second, and the third. I'll leave some space in between. Okay, and third. Okay, so I'm going to start with the equation x squared plus y squared is equal to r squared. So we can derive it, and I'm going to solve. I'm going to solve for one of the variables in terms of like make it become like a 1. So if I take my r squared and I divide everything by r squared, okay, what I'm going to get is I'm going to get x squared over r squared plus y squared over r squared, and that's going to equal 1. Now, when I have 2 exponents, using my exponent rules, I could pull the exponents out, and I can see it like that, and again, it's still equal to 1. So notice that we've seen x over r before, we've seen y over r. These are part of your trig, and this value gives you cosine squared of theta plus sine squared of theta, and we can set that equal to 1. Now, there are a lot of different ways that we can manipulate this equation. I'm going to change my color. I can rewrite cosine and sine, so I could rewrite it as sine squared plus cosine squared. That's equal to 1. I could solve, I could subtract. So cosine squared could be 1 minus sine squared of theta, or I could subtract the other way around, sine squared of theta, so 1 minus cosine. So again, I can manipulate this to whatever I need it to be. All right, let's try a different one. So x squared plus y squared is equal to r squared. Okay, so this time let's divide by x's. So x squared, x squared, x squared. So what is that going to become? That becomes a 1, and that becomes a y over x. I'll take that as a squared, and then r over x squared. Now again, I've seen the y and the x before, so this will become 1 plus tangent squared of theta is equal to secant squared of theta. Again, I can manipulate this one. This could be tangent squared plus 1 is equal to secant. I could subtract. I could say 1 is equal to secant squared minus tangent squared. Or I could subtract the other way around. Tangent is equal to my secant squared minus 1. So whichever one I want to manipulate is perfectly fine. Okay, so notice that I used, I have 6 trig functions. I've used 4 of them. So it's safe to say that we haven't seen cotangent or cosecant. So notice what happens when we divide this time by y squared. So divide everything by y squared. I'm going to get x over y, there's your cotangent, plus 1 is equal to, and then r over y, there's your cosecant. So cotangent squared of theta plus 1 is equal to cosecant squared of theta. So these will always go together. Again, I can manipulate it in 3 ways. I could write the 1 first. 1 first, there we go. And again, set it equal to cosecant. I can manipulate it by saying 1 is equal to cosecant minus cotangent. Or I could say cotangent is equal to cosecant squared minus 1. So again, 3 different ways that I can manipulate it. You really just need to memorize one way, and then you can go back and forth and figure out how you're going to manipulate it. Okay, the last one, and notice that all 3 have a 1 in common. That's that's the only thing that's in common between them. All right, last but not least, we have the negative angle identities. And so basically this one states that if you have a negative angle, say negative theta, this is the same thing as saying sine of theta, but making it negative. Okay, same thing works for its reciprocal. Right, so I pull out the negative. Oops. If I pull out the negative, I should not write the negative inside. So why does this kind of work? Okay, so let's take a look. Let's take a look at sine of negative 45 degrees. Right, so if I take a look at that, I know that negative 45 degrees leaves me with the 4th quadrant. So I know that that's equal to negative root 2 over 2. I still want to use the same number, but I want it to be negative. So if I just say sine of 45, that will give me just a regular radical 2 of 2. So how do I make it negative? I have to multiply it by a negative, which means now it's a negative. So that's why sine kind of works the way it does. For cosine, so cosine is an even function. So when you have a negative theta, it actually doesn't matter if it's negative or positive. It will always be the same as if you took the theta of a regular angle. And same thing with its reciprocal. So secant of theta is the same thing as secant of negative theta. So again, why is this true? Again, let's just take the cosine of negative 45 degrees one more time. This one, because it's in the 4th quadrant, is a positive root 2 over 2. Again, I want to use the same value. So notice that the cosine of root 45 is, again, still root 2 over 2. And again, it doesn't matter. I could have gone negative 120, right? 120 degrees, that gives you a negative 1/2. Positive 120 still gives you that negative 1/2. So it ends up being in the same quadrants. Finally, tangent. Tangent is very similar to sine, which means that cotangent is also the same. These will just pull out your negatives. So again, let's just do tangent of negative 45 degrees. So again, I'm in the 4th quadrant. I know that that's negative 1. Where else am I negative? I'm negative in I have to be negative in the third quadrant. But again, if I'm only using positive 45, right, if I use just a regular 45 degrees, that again gives me that positive. I want it to be negative, so I got to put the negative on the outside. And cotangent works exactly the same way. Okay, so let's see, how do we actually manipulate and use these examples to solve or simplify expressions. Okay, so let's use our identities to obtain an equivalent expression and then simplify. Right? You can using sine and cosine trig will help. Right? So again, that's kind of like a little hint. So if you ever have sine and cosine, or when you're stuck and you don't know what to do, change things to sines and cosines, and it seems to help out. Okay, so let's take a look at a couple examples. And so secant of theta times cotangent of theta and sine of theta. So there's no multiplication necessarily written in here, but we can tell there's no addition sign or subtraction sign, so it's safe to say it's multiplication. Okay, so they're all being multiplied. I need to come up with an equivalent equation. I don't necessarily know what to do first, so I'm going to follow my own hint. I'm going to write things as sines and cosines. So secant, I'm going to say that that is the reciprocal, so 1 over cosine. Cotangent, I'm going to use my quotient property to rewrite that one. And then sine just stays as sine of theta. Now I can write that over 1 if I want to. Okay, and then what I notice is that there's a cosine on top and a cosine on bottom. I also know that there's a sine on both the top and on the bottom. So everything kind of cancels out. Really, you'll just be left with 1 on the top and 1 on the bottom, which ultimately just simplifies down to the number 1. So if you want to try a couple of these problems out on your own and pause the video and kind of see what you did, by all means, please do so. If not, let's continue. Okay, so what do you notice about this one? I notice that cotangent seems to be multiplied. So there's, again, a couple different ways that we can approach the problem. There's no right way to always start it, but here's one of them. So I'm going to go ahead and I'm going to multiply cotangent to everything, right? I'm going to distribute that. So it just becomes cotangent of theta, and then this will become cotangent squared of theta, tangent squared of theta. What do I know? I know that these two are reciprocals, and when we multiply reciprocals, regardless if it's squared or not, that is going to leave me with 1. And when I have cotangent plus 1, that is the same thing as cosecant. Now I do want to show this in a different light, so I'm going to do this one more time. So I can say or. So what happens if you didn't distribute, right? You looked at this problem and you said, I don't want to distribute, which is totally fine. I notice that that is a Pythagorean identity. So let's go ahead and change it to secant of theta. Again, now it comes back to multiplication. I'm going to go ahead and change cotangent to cosine squared over sine squared. Again, I can use that identity. And then secant is really 1 over cosine squared. What do I notice? The cosines, they cancel away, leaving you with 1 over sine squared, which again is the same thing as cosecant. So a lot of different things that we could potentially do. All right, so for the rest of the examples, I'm pretty much going to just show one way. Right, so let's try another one. So what happens if you see something that looks like this? So secant, we say secant of theta minus 1 and secant of theta plus 1. So here's our example. Okay, so what do we notice about this problem? So again, when trig kind of throws you off, ask yourself, well, what would you do if it was not trig, right? So I see parentheses, I see some addition and subtraction signs. So for instance, what would you do if we said x minus 1 and x plus 1? right? You see two binomials, chances are you'd multiply those binomials together. So why can't we do the same thing with trig? So I'm going to multiply the secant and the secant. They happen to be the same thing, so it becomes secant squared. Multiply the secant with the 1, so that's just going to become secant of theta. Multiply the negative 1, so this becomes minus secant of theta, and then the negative 1 by the 1, so minus 1. What do I notice? I notice that these are opposites of each other. So again, knowing my algebra, I know that they will cancel each other out. So secant of theta minus 1. Together, that is one of the ways that we can manipulate our Pythagorean identity. So ultimately, that simplifies down to just our tangent. All right, let's try another one. Tangent of negative theta. So let's throw in a negative angle, and then the secant of theta. All right, when I look at this problem, again, sometimes the fraction throws me off, but I have to remember that it's being divided by secant. So this is the same thing as saying tangent of negative theta times 1 over secant of theta. I can kind of do a couple steps in one. So I see the tangent, I'm going to pull out the negative attached to it, right? And for secant, I'm going to go ahead and write that as cosine. And then tangent, again, is sine of theta over cosine of theta times cosine of theta. What do I notice? Those two cancel away. And my answer is just negative sine of theta. Okay, let's try two more examples. Hopefully we are starting to kind of understand what we're looking at, what we're looking for. Okay, if you want to try this one again on your own, I'm going to tell you what your answer should be. So if you want to pause the video and try it, you should get cosine squared of theta times the sine squared of theta. So if you want to pause the video and try it, by all means, go right ahead. Okay, so what do I notice about this problem? Second I see squared and I see addition signs, Pythagorean identities pop into my head. So 1 minus sine squared of theta is a way that I can rewrite it, and this is really cosine of theta. Cosine of theta is going to be in the numerator, 1 plus cotangent, that squared gives me my cosecant. Oh, I forgot the squared sign up there, cosecant of theta. Again, these are being divided by each other, right? So this would be the same thing as just saying divide by, right? Or I could say multiply, doesn't matter. Multiply by 1 over cosecant of theta. What do I know about cosecant of theta? I know that its reciprocal is sine squared of theta, and that is our answer. So if you were successful on that one, congratulations. If you weren't, that's okay too. All right, let's try one more. So secant of theta plus cosecant of theta, and then cosine of theta minus sine of theta. So again, if you want to try this on your own, the answer you should get is going to be, I'll put it down at the bottom, it's going to be negative tangent of theta plus cotangent of theta. Or we could rewrite it as cotangent minus tangent. So it just depends on what you do. Right. So what do we notice about this one? Okay, well, I notice again, there's two binomials. So I'm going to take into consideration what I did here on example 3. I'm going to multiply my values together. Okay, and remember, when we multiply things, it's okay if they're not the same, kind of like example 1. We just write them all together, secant, cotangent, sine. So I'm going to multiply these guys together. So this will become secant of theta cosine of theta. Multiply it by the sine. So minus sine of theta, secant of theta. It doesn't really matter which one you put first. And then we'll go here. So plus cosecant of theta cosine of theta. And then minus sine of theta cosecant of theta. All right, so what do I notice? I notice that this is a reciprocal. And so reciprocals give you 1. I also notice that this is a reciprocal. So that will also give you 1. Now they're opposite, so that's exciting. So let's figure out kind of what's happening in the middle right here. So I kind of, again, if you get stuck, ask yourself, okay, where do I need to go? Tangents are made up of sines and cosines. So what I think I'm going to do is I'm going to change secant to 1 over cosine. And I'm going to change cosecant to 1 over sine. So I could do this step in one step, but I'm really going to show you kind of what's happening. You'll multiply these two together, and then you'll multiply those two together. So what do we notice, right? The 1 and the -1 cancel out, and you'll just be left with this, negative tangent of theta plus cotangent of theta, because these two right here, this one and this one, cancel out. All right, and that's how we kind of manipulate expressions with our fundamental identities.